us take the second case. You take the rigid body, any 2 points you consider point P and point Q. This point let move in this way, this point let move in this way with velocities Vp and Vq respectively. Now you drop a perpendicular onto this velocity vector Vp which passes through the point P, and that perpendicular should lie in the plane of the body. We are taking the bodies as laminas or plate like. Next perpendicular you drop onto the velocity vector Vq which passes through Q and must be coplanar with the perpendicular number 1. These two perpendiculars meet at this point. Let this point be O. Let us take the point of intersection of these two perpendiculars as O. This O is instant axis of rotation. Why? Let me explain. So, case 2, if the velocities of any 2 points are given, say Vp and Vq. What do you have to do? Draw 2 perpendiculars. One and 2 at P and Q onto the velocity vectors Vp and Vq respectively. Number 1 step. Second step, produce these perpendiculars. The point of intersection of these perpendiculars is the instant axis of rotation. Needless to mention, these perpendiculars must be coplanar because you have to draw the perpendiculars onto these velocity vectors in the plane of the body. This is the plane of the body. The perpendiculars 1 and 2 must lie in the plane of the body. This is the idea. So, this point O, let it be at a distance of r1 from the point P and at a distance of r2 from the point Q. If this point P is instant axis of rotation, velocity of the point O is 0. So we have to prove in reverse way. If O is instant point of rotation or instant axis of rotation, velocity of the point O is 0. So we can imagine that this point O is pivoted instantaneously. When it is pivoted, this point P's velocity will be equal to how much? R1 into omega. At this point P, Q's velocity will be equal to how much? R2 into omega. Therefore, R1 can be written as Rp by omega and R2 can be written as Vq by omega. R1 is Vp by omega, R2 is Vq by omega. Mathematically we get it. In other words, we can say that this instant axis of rotation or instant point of rotation O is situated at a distance of R1 from the point P and at a distance of R2 from the point Q. This is the idea. So when the points move, these velocities are the velocities with respect to ground. For O to be instant axis of rotation, these velocities must be perpendicular to the radius vectors. When it is instant axis of rotation, this point can be assumed to be pivoted at that instant. So it will be some sort of circular motion type, some crude idea, the rough idea to get the theory. Penetrate to your mind, we have to think that it is pivoted instantaneously. It is not permanent pivot. In that way you have to think. Well, using this idea, let us solve a couple of problems. Let us take the familiar example of the sliding rod. The rod slides. Let us assume that this end slide with the velocity v, this end slide with the velocity v dash. This is given and this angle theta is given. Find instant axis of rotation. This is point P, this point Q suppose. Let us drop the perpendicular as per the theory. At the point Q onto this velocity vector v dash. At the point P onto the velocity vector v. These two perpendiculars 1 and 2 meet at this point O, and this is instant axis of rotation. Some student may think that this is the instant axis of rotation. These are the perpendiculars. This is wrong. These are the lines parallel to the velocities. These are the lines 1 and 2 perpendicular to the velocity vectors v dash and v respectively. So this is at a distance of r1. The instant axis of rotation is at a distance of r1 from q or r2 from p. And r1, r2 very easily you can calculate. If L is the length of the rod, the positions of instant axis of rotation O is given by R2 is equal to V by omega, or R1 is equal to V dash by omega. You can imagine that this is some sort of temporary pivot, and this is just like an extended body, and this is, you have to imagine that this some sort of lamina or plate which coincide or which contains the rod. This is an imaginary lamina. This slides in this way so that this point is lying inside the imaginary plate or extended rod or outside the real rod, which doesn't move at that instant. That is the instant axis of rotation, which is at a distance of R1 is equal to V dash by omega or R2 equal to V by omega. Here omega we can calculate. Here omega already we have calculated to be V upon L cos theta. Therefore, R2 is equal to V by L cos theta is L cos theta. In this way you can calculate, or if theta is given, L is given, you can just write R1 is equal to L cos theta. R1 is equal to L sin theta, or R2 is equal to L cos theta. So, R2 is equal to V by omega, or R1 is equal to V dash upon omega, omega equal to V upon L cos theta. Well, in that way you can write, where R2 is equal to L cos theta and R1 is equal to L sin theta. Therefore, is answer. The position of the final instant axis of rotation. The instant axis of rotation is this, which is located at a distance of R1 from point Q, that's equal to L cos theta, L sin theta, and R2 is equal, or R2 or and R2 is equal to L cos theta from the point P. Using the concept of instant axis of rotation, next you can write, find the angular velocity of the rod. Once you get the instant axis of rotation by using simple geometrical idea based upon the theory I discussed, under the condition that the velocities of any 2 points are given and these 2 velocities are directed arbitrarily, they need not be parallel. Then you substitute R2 here to get omega is equal to V by R2. And what is R2? L cos theta. So, using the concept of or the method of instant axis of rotation, we can also calculate the angular velocity of the rod. Or if you choose to use this formula, we can write omega is equal to V dash by R1. But what is R1? R1 is equal to L sin theta. But we do not know V dash. But V dash can be calculated by equating the velocities of these points along the rod. This component is V dash cos theta, this component is V sin theta. So, equating the velocities along the rod, because there is no relative velocity between any 2 points along the line of connection. As per the principle of rigid body, we get V dash cos theta equal to V sin theta. So what is V dash? V sin theta by cos theta. If you substitute V dash here, you can get the answer. V sin theta by cos theta by L sin theta. Sin theta will getting cancelled. Ultimately, you are getting the same answer. Omega is equal to V by cos theta, L cos theta. Either you follow this formula or this formula, doesn't matter. Ultimately, you will be getting same answer. Let us discuss the last case of calculation of the instant axis of rotation. When the plate-like rigid body is rotating in the plane of the board, and 2 points we are choosing when they move along the same direction or in opposite direction. In other words, we can say that when these two velocities are parallel or anti-parallel, then how to calculate the instant axis of rotation? If you just put the points like this, suppose this point 1 or this point P moves with velocity Vp, this point Q moves with velocity Vq. In same direction or they may move in opposite direction. You drop the perpendiculars onto the velocity vectors at these 2 points. They will meet at infinity. They will meet at infinity. Does it mean that the instant axis of rotation is located at infinity? Obviously no. If we produce the perpendiculars dropped onto this velocity vectors at P and Q respectively, they will meet at infinity. Does it mean that the instant axis of rotation is located at infinity? Obviously, no. Then you have to find different principle. You have to find the different technique, to follow the different technique to calculate the instant axis of rotation of the rigid body when 2 points velocities are antiparallel or 2 points velocities are parallel. So the first step is, under this condition or the case when two velocities are parallel or antiparallel, how to calculate the instant axis of rotation? So for this, let us choose a point O as instant axis of rotation. Since VO is equal to 0, this point is imagined to be stationary at that instant. You can choose a point O. Imagine that point as a temporary pivot because velocity of the point O is 0. Furthermore, assume that these 2 points are located at a distance r1 and r2 from P and Q respectively. From P, R1, from Q, R2. Such that the angular velocity of the rigid body will be omega. When this is the pivot, we can write VO is 0 in both the cases, and these velocities Vp is perpendicular to R1, Vq is perpendicular to RQ or R2. Vp is perpendicular to R1, Vq is perpendicular to what? R2, both the cases. Vp is perpendicular to R1 and Vq also is perpendicular to R2. Well, since the angular velocity of the body is assumed as omega, we can write Vp is equal to R1 into omega and Vq is equal to R2 into omega. Vp is equal to R1 omega and Vq is equal to R2 into omega. If you divide these two equations, omega will be getting cancelled. You are getting Vp by Vq is equal to R1 upon R2. You divide these two equations, omega will be cancelled. So Vp upon Vq is equal to R1 upon R2. This is the condition. Under this condition, you can develop a geometrical technique. What is the technique? Let us join the tips of the vectors, and already you have joined the tails of these vectors, and we produce two similar triangles. Let us join the tips of these vectors. Already you have joined the tails of these vectors Vp and Vq, and we are producing bigger triangle and smaller triangle, two similar triangles. This common expression gives us the idea that the instant axis of rotation is located at the point O, which makes two similar triangles in both cases. Here Vp is parallel to Vq. Here Vp is antiparallel with Vq. parallel or anti-parallel. In both the cases, you are getting two similar triangles. So, in this triangles, always this side, that is Vp, upon this side Vq is equal to this side is R1 upon this side, this is R2. We can signify this expression geometrically in this way. In the other way, we can say that the Vp upon R1 is equal to Vq upon R2, and that is the angular velocity of the rigid body. Here we can write Vp upon R1 is equal to Vq upon R2, that is none other than the angular velocity of the rigid body. This is the theory to calculate the instant axis of rotation when two velocities of any 2 points, given points, are parallel either or they are anti-parallel. Because following the previous technique, if you produce the perpendiculars dropped onto these two velocity vectors at these 2 points respectively, they will meet at infinity. So, using this procedure, we can get the instant axis of rotation is located at infinity, which is baseless. Therefore, we have to concoct this theory that let us assume O as the instant axis of rotation. Since it is instant axis of rotation, by logic or by basics, this point should be stationary at that instant. When this is stationary, these 2 points must move with velocities with respect to this point Vpo. Since O is stationary, this is equal to Vo. Vpo, that's equal to Vp because O is stationary. Vq O, that's equal to Vq because O is stationary. And these velocities must be perpendicular to these lines. And rest of the theory will follow it. Ultimately, we are getting or converting all these ideas to geometrical ideas. That step 1, join the tails of these vectors, join the heads of these vectors, where they intersect, that is the instant axis or instant point of rotation. Join the tails of these vectors, join the heads of these vectors, where they will intersect, that is the instant axis of rotation. And by using the principle of similar triangles, we can get the omega, the angular velocity, and the position of the instant axis of rotation, that is either R1 or R2 in both the cases. Let us execute this idea through a couple of examples. An example to justify the third case. Of a disk undergoing a combined motion. Let us assume that the disk is rolling over the plate number 1 and plate number 2 is also rolling on the disk with velocity v and 2v. For pure rolling, find instant axis of rotation and find the angular velocity if radius of the disk is r. This is the question. For pure rolling, between these 2 points of contact, at this point 1 and 2, there is no sliding. Therefore, this point 1 is moving with velocity 2v in leftward direction, and the point 1 or point 2 is moving in rightward direction with velocity v. Because the velocity of the plates at these points 1 and 2 will be equal to velocity of these points of the disk, because as per the condition of rolling, the contacting points, there are two contacting points. When the two surfaces they touch, this may be a common point, but one point is on the surface number 1, another point is on surface number 2. There are two contacting points, and these contacting points should not slip or slide. Therefore, at this point 2 on the disk, the velocity is v in this direction. At this point 1 of the disk, the velocity will be in left direction and the speed is 2v. Well, this comes under the condition what we discussed in the third case. Two velocities are given, they are antiparallel. So, what is the logic? The logic is join the tails of these vectors and join the heads of these vectors. They intersect here, and this is instant axis of rotation. Let it be O, let it be x, and this will be 2r minus x, because this is the diameter. Now, you can use the either principle of rotation, or you can use the principle of similar triangle. These two triangles are similar. Hence, omega is equal to v by x is equal to v by x is equal to v by how much? 2r minus x. V will be getting cancelled from both the sides. So, by cross multiplication you are getting 2r minus x is equal to 2x, and x will be equal to 2r by 3. So, the instant axis of rotation is located at a distance of x is equal to 2r by 3 from the top, or 2r minus 2r by 3, that is 4r by 3 from the bottom point 1. So, we have calculated the location of instant axis of rotation, then to calculate omega, and that is equal to, you can substitute x here or in this equation, v by x, v upon 2r by 3, you are getting 3v by 2r in this direction. So, using the concept of instant axis of rotation, directly also you can calculate the angular velocity of the rigid body when 2 points velocities are given, either antiparallel or parallel. I will take the case of parallel velocities in the final example. Let us take another example where this plate is moving with velocity 2v, and this plate is moving with velocity v. What is instant axis of rotation? Now, what is the angular velocity of this body? Let us draw the diagram. For pure rolling, this point 2 of the disk will move with velocity 2v, and this point 1 of the disk will move with velocity v. Now, join the tips of the vectors. Join the tails of these vectors, then join the tips of these vectors and produce them. They will intersect at this point. Let it be O. This is instant axis of rotation. join the tails of these vectors, join the tips of the vectors, or this is 3v, let it be v, and they will intersect outside of the disk here. Let it be O. This is instant axis of rotation, and this forms this bigger triangle and this smaller triangle. These two triangles are similar. Using the idea of similar triangles, this side upon this side is equal this side upon this side. Let it be x, and this is 2r, we know that. Therefore, from here to here, the distance is how much? 2r plus x, isn't it? Yeah. Now use the idea of similar triangle, 3v upon this distance, that is 2r plus x, is equal to v upon x, and this is nothing but angular velocity of the rigid body in this sense, and you can think that this is some sort of pivot temporarily at this instantaneous pivot, but it should not confuse you that it is pivoted for all the times. So v will be getting cancelled. So 3x is equal to 2r plus x, and x is equal to r. So this point, instant axis of rotation is located at a distance of r, or radius of the disk, with respect to the lowest point of the disk below. Answer. And substituting the value of x here or in this equation, omega is equal to v upon x. X is how much? R. So the angular velocity is v upon r in clockwise direction. So that's the idea. To calculate the instant axis of rotation under three cases. Case number 1, when velocities one velocity of any one point is given and its angular velocity is given. Case number 2, when 2 points are given and their velocities are given, the velocities are not parallel or antiparallel. And case number 3, when 2 points are given and they move along the same direction or they move in opposite directions. Under these 3 different cases, we discuss the theory of calculation of instant axis of rotation, followed by these illuminating examples. In the next class, we will talk about some common examples. In addition to the remaining concept, what the JEE question setters are very fond of asking, radius of curvature of a rolling body at an instant.